Good afternoon. Let us dwell for a moment more in those gaps where we can make the unseen visible and manifest latent structures of human creativity to discover new instances of creation in between what we've already made. So some of what we've made lives in museums, where at any given time, only 10% of a collection may be visible. But about 50 years ago, a trend began to democratize museum shows, or take all of the instances of objects that are hidden away in warehouses and in storage, and to put them in open stacks where visitors could see them. And this first happened in the Department of Anthropology at the University of British Columbia in their museum. But in 1998, the Metropolitan Museum of Art opened the Luce Center, the Henry Luce Center for Visible Storage, where they did something similar and took most of their objects of American art that were hidden away in warehouses and put them in this delightful visible storage. And the excellent thing about this visible storage is that it challenges this relationship between what's made and what we choose to display. For what's made represents this vast structural language that can also be used to describe the single instances that we observe. And so we start to interrogate the relationship between these two things when we walk through these glass cases of visible storage, which have actually become quite popular, with other instances at the Victoria and Albert Museum in England and at the Brooklyn Museum with their famous picture wall pictured here. So all of the instances here are instances of human creativity that we can use machine learning to infer a latent structural model underlying all of these unique instances, and then start to build a structural language for generating other such instances based on what's already been made. And we had the chance in a recent collaboration with the Met Museum and Microsoft and MIT to put this thinking to the test. In 2017, the Met released an open access catalog of over 400,000 of their digital works that had been scanned, and they were put into the public domain. And they wanted to use AI to both explore the context of this collection in ways that people could interact with and discover it, and to use it as a tool for education. And so this past year at MIT, with the team from Open Learning and with the Knowledge Futures Group, we put together a collaboration between the three institutions to see how we could bring machine learning to bear on the Met's open access digital collection. And so last year in December, we put together a 2-day hackathon where teams, including myself and Matthew Ritchie, experimented on using machine learning to explore the Met Digital Collection and to, as we'll see, to create some new work. And then just a couple of weeks ago, we had a reveal at the beginning of February where certain projects from this showcase with the Met were put on display in the Great Hall of the Met for just one night. And so we could take objects like we see here in the Met's online collection, and we can use them as training data for world models that can begin to infer from instances of human creation this structural language underlying them. And so we can think about these vast numbers of works in the public collection as training data for a generative model that can then be used to generate new instances of work, which is thinking about existing work as statistical instances or samples from a model, and we can create future samples that explore the spaces between what's already been made. So here we see vases and pitchers in the Met's collection, and then we see interpolated vases, or vases that could exist based on what already does. And so to do this, we found nearest neighbors for each object in the Met's digital collection in certain categories in large trained world models, such as BigGAN or ProGAN trained on the Met digital collection itself. And we can find sort of the closest object corresponding to something that exists in the latent space or the sea of this neural network that has learned something about structure underlying creation. And then we can use this for a couple of things. We can use it to interpolate existing collections and to iterate them forward. And so in interpolating, we can explore, based on what's already been made, other objects that could exist in those spaces between works in a particular archive, and we can iterate by generating thousands of variations and then selecting features that are particularly compelling to drive the next generation of outputs. And so here we've got a wander through the latent space of BigGAN corresponding to sets of objects in the Met collection. And on the right, we have pairs of objects, existing objects on the left, and then generated objects on the right. And you can imagine generating thousands and thousands of these and choosing features that you might want to fabricate, as we've seen earlier today, in real life, and start to build a complex collaborative ecosystem where we can work with parts of our own culture represented in parallel to us executably in software, such that we can collaborate with these long trends and collectively curated models quite explicitly. Rather than having to manifest them in instances of individual inspiration, we unlock this whole other world of making this automatic and making it scalable and allowing other people to interact and iterate and explore styles that might have been developed thousands of years ago. So we can look at large sets of these generated instances, and they start to inspire, for me, the feeling of what we saw when we wandered through those glass cases and the visible storage, right? Where when you're wandering there, you might see rows upon rows of bowls where handles have slightly different curvature, or ceramics of increasingly intricate patterning. And when you look at each instance, just as you look at each teapot here, you simultaneously experience its uniqueness, owing to particular parameters that were used to generate it, as well as its potential to be iterated, because you understand that the model used to create it could be run again. So this is a very different type of flavor of uniqueness than that of the single work behind a piece of glass, for instance. It's a uniqueness that is not conflated with scarcity, because everything that you see here, you can remix and modulate and recreate yourself. So because we have the power to remix and modulate with articulated models for making, the way I like to think about what we're doing is creating a shared and executable language for aspects of human culture that have been curated across millennia. And this has the potential, using machine learning and artificial intelligence, to rekindle a very ancient relationship to making, where the creation of beauty was the enactment of a beautiful process and the manifestation of cultural structure that had been collaboratively authored over generations, right, in a particular region or at a particular time. With AI models, we can give people access to that, and so it's very critical that these models become a shared resource and allow people to interface with culture that's collectively tended. As part of the collaboration with the Met and Microsoft, we built an online studio where people can interact with the models underlying the Met's collection and generate their own instances of artwork and discover what might lie in the spaces between what's lying in the Met's collection already, and then move, as you saw, across the map, which is a spatial way of understanding the latent space underlying a collection. Rather than just toggling features, we allow people to move through a visual depiction of space, where features are captured by one's proximity to other objects represented on the plane. And then, once you've found a particular object that's compelling, you can use that to discover other objects in the Met's collection that are visually similar. And so we're linking these collections together and allowing people to explore features in their manifestation in a way that is executable and iterable, rather than linked to specific works that are locked in one place in time. The importance of developing shared models and models as a shared resource will only increase as we start to lower the boundaries for these long, complex chains of collaboration that collapse these traditional notions of authorship that we have. As we develop models that have the ability to be modulated and run again and to iterate and to live in ecosystems, we need new considerations of attribution and of authorship. And we need infrastructure for making collaborating with these models a new norm. If you'd like to collaborate with us, we've got a couple of resources online, and we also have a set of how-tos and demos corresponding to the Met, Microsoft, and MIT project on PubPub if you'd like to build your own studio or run your own hackathon. Thank you.